Yes, thanks a lot. It's a pleasure for me to share some insights regarding the assessment of marine food webs, and also based on some early experience that is being carried out also in Italy in the context of the implementation of the Marine Strategy Framework Directive. What are food webs? Basically, the food webs are complex systems where species interact one with each other through trophic linkages and relationships. And through these relationships, they generate a dynamic and a dynamic equilibrium that then generates some emerging properties like resilience, resistance, and persistence of the whole ecosystem itself. And here you can see just a scheme of a representation of such relationship that is taken from models that are implemented, mass balance models that are implemented in order to study food web dynamics and ecosystems, and it could be seen somehow as a simplified representation of what is the reality. But we know that food web have properties that could be considered and studied to have an understanding of the whole condition of the ecosystem. The point is that within ecosystems and within the food webs, not all species are equal. On the one hand, they could play different ecological role, and the loss of some species could then generate disproportionate effects in some cases on the ecological processes. At the same time, species could be grouped in groups like trophic groups, trophic guilds, together because they could have similar or common behavior within the food webs. When you remove some species or some groups, some trophic groups from the ecosystem, you could have some overall and global effects on the ecosystems that could propagate through trophic levels within the whole ecosystems, generating changes through the trophic cascade. Here are some schemes that I refer to the effects of the removal of some predators. Could be predators on sea urchins that can then in turn generate, the explosion of sea urchin, and then predation and grazing on algae. And this is an example, of course, from the Atlantic, but the same holds true, for instance, for the Barents in the Mediterranean Sea, where fishing removing predators on sea urchin enhanced the dimension of that population, that in turn increased grazing, and then in turn reduced biodiversity. At the same time, within the ecosystem, we have, of course, environmental drivers that affects the whole systems, and that could determine a control from the bottom-up control, for instance, increasing the productivity of the system that propagates up to the higher level, or other drivers that could be human-induced, like exploitation of top predators that could then propagate to the lower part of the ecosystem. What happens is that the integration of environmental drivers and the presence of human induced drivers can generate regime shift, as they're called, within our ecosystem, so change the overall structure of the system, and passing through some tipping points that are bifurcation, generate some alternative status of the system from which it's not possible to come back. So you have another shape of the ecosystem that is expressed in front of you. Of course, all this generates somehow the need to have an understanding that is more holistic of what's going on the ecosystems, and have an understanding of the status. And food webs could be the analysis of food webs. So then the analysis of the ecosystem, its structure, but also its food dynamics can be instrumental in this regard. And that is why it would be necessary to monitor it. And there are several fold reasons. So to understand what is really the status of the ecosystem, so in a world sense, but also to support the application of a holistic approach like the ecosystem-based approach that we know is applied somehow in a reductionist approach, measuring species, group of species, communities, but could be further investigated also with more synthetic visions and studies. At the same time, through the study of food web and integrating this study with the assessment of the different pressures and drivers that are exerted, that we could also understand what is the cumulative effects of different pressures, and then in turn also allow for the interpretation of what is happening even at the lower levels, because in some cases, trends in species groups could be determined not by direct pressures on the species group, but by indirect effects that propagate through the food web within your ecosystem. And having this information, especially in the context of environmental change, climate change, and having understanding of that process, and later on there will be today another presentation that focuses on this, is relevant to inform decision makers regarding what would be the possible future scenarios, and also to set some adequate management goals that without this understanding could be biased by the lack of full information on how the system is working and what would be its dynamics. So when you want to assess the food web, you can consider some more synthetic some groups that are presenting some common properties in terms of their role within the food web. So focusing, for instance, on the trophic yields, or focusing on the communities, or if you have the opportunity to focus on the whole ecosystem, then through models, you could use what are called ecotrophic groups that are used, for instance, in the modeling through within the approaches like the mass balance approach, like those with the that are developed within ECOPAT and ECOSYN. And you could, these are the elements, so species groups, trophic guilds, communities. You could assess them through considering some specific parameters attributed to these groups, focusing on abundance of biomass, or focusing on other aspects like their diversity, their size structure, considering attributes like the trophic level, that is the trophic position of the species group, or the trophic yields of the species within your ecosystem. Or you could use other kind of approaches like the ecological network analysis, trophodynamic indicators, and other ecosystem indicators. And there are several parameters. I believe also that in the document that has been shared by the Secretariat, I mean, both the indicators that could be used and the approaches that are being developed so far are well represented, and you can relate to that. And beyond the indicators and the elements that are considered, then there are also the drivers that should be taken into account when making your assessment on what is the trend, the condition of your ecosystem. That includes the different drivers that, as we were saying earlier, they could act cumulatively together. So this includes climate change, fisheries, nutrient loads, and the other pressures, but also the natural forcing that you have, so changes in oceanography and physical conditions. And basically, there are two interlinked approach that could be done. So on the one hand, you use the data, the actual data from the environment, so the real field data, and through these you generate some indicators. Or you use this data and you integrate them through a modeling process, and you use a modeling approach to understand the trends on trophic yields, for instance, or from ecotrophic group, or the whole system, maybe applying also some assessment from the ecological network analysis. We have to be clear in reminding us that the methodological standards for these assessments are not fully developed. There has been for sure, the development of many indicators and also the adoption of many indicators in some regional sea conventions. Here I'm going to represent what has been the approach that is being implemented by Italy in the context of the Marine Strategy Framework Directive in relation to the Descriptor 4, that is parallel to the Ecological Objective 4. Within the Marine Strategy Framework Directive, the Descriptor 4 is qualitatively described as all the elements of the marine food webs, to the extent they are known, occur at normal abundance and diversity and levels capable of ensuring long-term abundance of the species and the retention of their full reproductive capacity. And this is somehow not very different from the earlier definition of the Ecological Objective 4 that relates to that focus on the alterations that are induced by humans, by resource extraction and human-induced environmental changes that should not have long-term adverse effects on the food web dynamics and their variability. So one focus more on the dynamics and the variability, the other focus on the elements and the diversity on the long term. The approach that has been developed so far within the Marine Strategy Framework Directive in relation to the food web has changed, has evolved. And in the latest version of the methodological standards that were released in 2017, four criteria has been identified, two of which are primary criteria and two that are secondary criteria. The first two criteria, the primary, relates to the diversity of the trophic yields and the balance of the abundance between the trophic yields. And while the other two that are not primary criterion relate to the size distribution of individuals across the trophic yields and to the productivity of the trophic yield. What is interesting to note is that trophic yield has become then the currency for the analysis that is proposed at the European level. And within the Article 8 guidance that has been released 2 years ago, there is a series of trophic yields that are proposed, 10, for the assessment. And as a general kind of indication is to try to capture both the lower part of the food web, so the primary production in particular, and then the mid part, and then the upper part that relates to the apex predators. The interpretation that was given from the Commission in relation to these descriptor and the use of the indicators is to use these indicators as surveillance indicators. That means to use the indicators and the applications of marine web to identify potential criticism, critical conditions, that should be then taken into account and better investigated through more monitoring and through more scientific work, rather than through direct measures that are more linked to the other descriptors and the different activities that are represented. So what we did in Italy for the implementation of the MSFD, we have established a working group within the MSFD monitoring programs, which includes, of course, ISPRA, that is coordinating the approach and implementation for the Marine Strategy Framework Directive and its assessments, and with the entities like the OGS, so the Oceanographic Institute from Trieste, who deals in particular with modeling and indicators, and other university which deals with stable isotopes analysis, in order to have a mixture of background contributing to the assessment. We've been working on the 3 subregions, and we equipped our assessment areas as the subregional seas, so the Adriatic, the Ionian, Central Mediterranean, and the Western Mediterranean. And we try to adopt as much as possible to be linked to the Article 8 guidance definitions. For our assessments, we have been using data that were coming from the data collection framework. So those that links to the troll surveys that are carried out in Italy since well, the Met, the northern part of the Met since 1994. We benefited also for the usage of mass balance models that has been developed for the 3 Cs. And also we developed a database and also some direct analysis of the biota to establish the stable isotope signature of the different species to inform our classification of species according to the trophic gills. And here you can see the 5 trophic gills, sorry, one part of the slide is in Italian, that we selected. So the benthic feeders invertebrates, the plantivorous invertebrates and fish, demersal fish subapex predators, pelagic fish subapex predators, and fish apex predators. Basically moving from a trophic level relatively low, from 2.4 on average, till 4.1 for the apex predators. So trying to move across different mean trophic levels and considering both demersal and pelagic species. We used only 5 gills because, well, we had the opportunity to assess also even more, but we had an understanding that the data for several reasons were not good enough to represent also some other gills. So, of course, this depends on the kind of monitoring that you have available. We have been addressing the 2 main criterion. One relates to the diversity within trophic gills, and then the diversity across trophic gills. And we used 3 different indicators, one related to the beta diversity, the Canton diversity, and Shannon diversity, that are different means to try to express diversity within and across the trophic gills. And in parallel, here you can see just some data just to let you see what kind of trends could be generated through the analysis, through the actual data, and also through the modeling data. And you can see that basically there was an agreement in between the models and the real field data that was limited in some cases. And we were able then to extract trends over time of richness of biomass overall, but also for the different trophic gills. And given this disagreement that could be between the actual data and the model data, we decided to use that and the actual data for our assessment and to keep, the model as being for further development. And we made an assessment at the comparison of the results from the over time, in particular comparing the latest part of our time series, so from 2016 to the 2021 period, versus the earlier part of the time series that was between 2005 and 2015. And these comparisons was not used to assess the good environmental status, because we felt that at this stage we don't have threshold values that could be applied for distinguishing between the good environmental status and not good environmental status, given the shortness of our time series. But we use this to assess whether or not the environmental target that were set by Italy was achieved. And in our case, the environmental target was to ensure that a good condition of the trophic gills was maintained or improved. So as compared to our baseline, this would have meant or to increase the biomass or to increase the diversity. So when we had an increase in biomass and in diversity of the trophic gills, then we recognized, we interpreted this as an improvement of the status of our trophic gills. So we made this assessment for all the trophic gills and the whole community, and we came up through the integration of the different indicators to these assessments that is here shown. The green saying that we're in good condition, and the red saying that we had some negative effects. So in parallel, as I said, we have been developed some tools that facilitate this, the assignment of species to trophic yields and to trophic level. And in particular, we built on the one hand a huge database of all published material in relation to all data for related to isotopic signatures in terms of carbon and nitrogen that helps to establish the trophic level of species, and also to assign species to trophic yields. And this database is now under submission. So and it will be shared, of course, soon with all the other countries. So we thought that this could be instrumental to help the countries to try to use a common approach also for the classification of species in relation to their trophic role within the system. So some remarks. Within our work so far, we were unable to track some parts of information. So especially those in relation to the primary producers that were not assessed in our case, and also apex predators could be broadened. So the point would be to expand in the future, and the general suggestion is to be able to capture the different processes that are there. So the productivity one, of course, is relevant. So broadening the number of trophic yields would be relevant for the assessment, and at the same time, we feel that adopting some indicators that are able to capture the whole ecosystems or communities could be relevant, like those that are related to the mean trophic level that we also applied but didn't use in our final assessment. Several attributes shall be assessed together. So biomass productivity, as I said, and also the biodiversity. We feel there is an added value in working and using both field data and the modeling approach. Field data are able to capture part of the information, and then if you want to have a more integrative approach, you have to use also modeling, integrating the two, and also being able to better align the outcomes of the modeling with the data that are actually for the field, validate the two processes. Such approach can also allow to embed into the process assessments of what would be the effects of climate change and other drivers, also within a cumulative effect. So, I mean, not as a short-term goal, but a mid or long-term goal that could be something that should be then included. We have the feeling that it is necessary to have common approaches overall for the identification of the role of the species and the definition in terms of trophic yields and trophic level when you work in particular on indicators that are linked to the trophic dynamic to the trophic level. And at the same time, we understand that the assessments should be done at sub-regional and regional levels, so not only on national level, because the ecosystems has not really national boundaries. So that is a call also for operating in such an approach and building such common assessment. And of course, we are happy to share our experience in the future, and we hope to be together a Mediterranean approach. So, thank you.